this is a session about choosing what API protocols, data channels, and formats to use. And real quick disclaimer: my views are my own, not my company's. And about myself, I work at Vex as a VP of engineering, but before that, I was in these places. The size of the bar denotes, how many years I had spent in these companies. And a real quick agenda and the outcomes. We want to take a look at how to choose the right API format and data channel. I'm going to take a look at three things. One, set of parameters that help us make a decision. Number two, we're going to take a look at some of the guidelines or generally accepted principles. And number three, we're going to take a look at some live examples of the world applications and what protocols and channels they use. And before we get there, though, we also want to talk a little bit about some of the basics of different protocols we have available. We're not going to spend too much time on them, so we're going to skip through many of those because they'll be very obvious to you. Just to orient ourselves on what an API protocol is, set of rules and regulations that decide how the message gets processed, how the data gets handled, errors get handled, as well as how status gets moved around. Data format is really just the specifics of how the data gets annotated, as well as how it gets serialized and how it gets sent over the wire. And the data channel just tells us, a transport mechanism, how the data moves. Is it bidirectional, unidirectional, multiplexed? And obviously also, is it allowing any state management or persistent, right? Protocols, we have tons of them. I've only mentioned a few. We're not going to talk about in this presentation in detail about these, but we're going to focus on a few of them that are relevant for our discussion. Quickly about REST. Everybody over here knows what REST is, but just want to focus on a couple of items, attributes of REST. One is that it's entity oriented, is based on entities, which is based on databases, and we create operations or things around each entity, whether we create an entity or delete, and so forth. And also it works in the request response mechanism. Basically, you send a request, get a response back. Of course, you can extend REST as well and say, hey, look, I send you a request, but when you have more data about this, please send it back to me using a webhook, in which you can decide, what authentication, retries, etc. you need to manage. You also can use OData framework, Open Data Framework, to allow for SQL-like language query within the URL itself. I did a session 5 years ago in this conference in which I talked about API usability and design guidelines, in which I covered some OData elements as well. Hypertext as the engine of application state allows us to embed some documentation, some entity relationship information, schema information within the API response as well. Now, GraphQL, nothing much to say about it, except for that whatever you're looking for, you're just denoting your request in that form. If you want a JSON format back, you send a JSON-like input, whether to receive the data or to modify the data as well. Similarly, it also has some subscriptions, which is very similar to webhooks as well. I'm not going to waste time on this one. gRPC, we're going to spend a little bit of time on this. If you look me up, 21 years ago, I wrote an article about SOAP, WSDL, and UDDI. And I feel like it's just not. And I mentioned that because in the company I work, we do have some SOAP services still, which are legacy based on some old systems. But we're trying to modernize them. gRPC is something we want to focus on a little bit. It is a little bit different from the REST paradigm. REST, by the way, is not really a protocol. It's a set of architectural guidelines and principles. But gRPC is a data channel as well as a protocol. Allows us to have a bidirectional duplex and binary channel based communication between a client and a server, or a server and a server. Google implemented that a long time ago. The full form is gRPC remote procedure calls, which is a recursive acronym. The key thing about that is that it allows the client to invoke some API methods on a library, thinking that they are local to them. And how it works is that it uses protocol buffers, which is not only a message format, but also it allows to have interface definition language. So the ideal that protocol buffer uses helps you define, here is what the classes are going to be, here is what the operations are going to be, and then you have a compiler, specific compiler called proto-C, that compiles the interface definition into the specific language that you're working with, C#, .NET, and Java and Python, etc. Now, Why is important? And second thing about, of course, protocol buffers is that you also have a message format that gets serialized and gets channeled on the wire as well. Um, HTTP2 is the basis of gRPC, was based on speedy protocol that Google implemented a long time ago. The key things in that is that it's also based on TCP, but it allows you to have that duplex channel. You send a request, you'll get a response. Maybe you'll get multiple responses. Maybe you send a request, multiple requests, you get no response or multiple responses, or have a streaming connection established between client and the server. It's meant to be fast. A lot of analysis has been done where gRPC and protocol buffers combination yields about 7 to 10 times faster speed when you compare it with the REST and JSON. And I did some analysis myself on this as well. It's in P99 or 99 percentile of the time. It is going to be as fast as 7 to 10 times. The only thing about gRPC to note also is that it only works with the protocol buffers. But the reverse is not true. Protocol buffers also can be used in a variety of other scenarios, which we will take a look at in a second. And by the way, if interface definition language reminds you of old days, think about Corba, right? If you have done coding long time ago, or DCOM, etc. WebSockets is also bidirectional, allows you to have real-time access to data. The only major thing to note about WebSockets is that it is text-based. So even if you send a binary object from the socket server, you're only going to get text back in the browser. It is very ubiquitous. Well, a little bit focus on the MQTT message queuing. Telemetry transport is meant for high latency when the system is not going to have a very high bandwidth and when the compute power is very low. In those kind of cases, you want to work with the pub/sub model where the data could get lost. So you define quality of service levels that, hey, look, whatever happens, please do send me some data. Or if you don't send me data, fine. It'll be nice if you send me data, right? So different qualities of service levels are available. And also you have something like called last will. If server is about to die or a device is about to die, they'll send the last will, some information back to the caller. Hey, I'm going to publish this. After that, I'm not going to be available. And we'll talk about in a little bit more detail on different use cases where it is used. Data formats now, everything is self-explanatory. Maybe protocol buffers, which we just talked about earlier, and message pack and Avro. Message pack is also JSON-like, but it is binary encoded. It's binary serialized, and Avro is also binary serialized. Difference between message pack and Avro is that Avro has more strong typedness. It has a more schema validation built in. We talked about protocol buffers and its attributes. And I mentioned to you earlier that it's not only usable in gRPC-based scenarios, but also you can use it in Google Firestore and Data Store in a native form. And obviously, you can also store protocol buffers compiled objects in a blob of any other database as well. But you won't have native access to its content. And it's not meant to be human readable. So it's going to be a binary data, so you can't just open up and read it. So you have to think about, okay, am I doing this for optics or am I doing this for performance? Data channels, real quick. We don't have to go through all of them. We already covered gRPC and WebSockets. But HTTP 1, 2, and 3 real quick. HTTP 1.1, most commonly used HTTP version, is text-based. It allows unity communication, send a request and send a response back. HTTP 2 is fully duplex, but it's also based on TCP. And then HTTP 3 is the latest version. It uses this quick protocol, which is a quick UDP internet connection. And it's high performance. The only problem is that it doesn't work in Apple's ecosystem. So it doesn't work in Safari on iOS or the Mac OS. So can't really use it. Data channel on WebRTC, it's a very interesting data channel where you're able to establish a connection with the peer. So you're using web application, you'll do a handshake via the server, and then you can communicate directly with the peer and send data, receive data. Maybe 11, 12 years ago, I went to HTML5 Dev conference and presented a peer-to-peer CDN that I built using data channels. It might sound nice, but it's very impractical use case because when you're trying to get data from somebody else who's using a mobile phone and they have limited mobile data available, now you're uploading a file through them, a CSS file or image file, and that comes to you. So using some other people's bandwidth. So it's really not that practical and really catch on. Let's take some examples where you have some gRPC services already built, and you want to expose that to the web browser. Of course, web browsers directly cannot call gRPC services because they're gRPC is binary, and the web browsers work with text. So could we have a workaround? So gRPCweb allows you to create a layer in front of the gRPC service. It's called the proxy layer that converts the binary objects into text format. And also, the gRPCweb allows you to create a JavaScript library on the client side for the web client that thinks that now I'm making native gRPC calls. Right? So you have objects, prototype files, generates the JavaScript components as well that you invoke API calls on. Of course, you're thinking you're calling local methods, but there's no binary communication available, so it's not as fast as gRPC natively. But also some use cases might be that you have a gRPC service, but you want to expose RESTful endpoint out of that. You can also do that using gRPC gateway, and that way you can cut down some time of going into production by just building brand new RESTful services. One of the other things that I was playing with recently was, using .NET Core, you can easily build web APIs, and they have been available for, I don't know, 20 years. But then you also can create gRPC services using .NET Core. But when I create services in .NET, I use the Entity Framework Core that allows you to have code-first view of creating your entities representation in the code. And what that means is that you create a class, and then you say, hey, by the way, this class will represent my entity, a table. And then I create a migration in which automatically the database table gets created based on my class. And then I can have a bi-directional sync between my classes and my database. It's a very common use case to create classes based on the database structure, but lesser common use cases to create classes first and then create the database structure. So once you do that, though, you have now ability using code to create records, delete stuff, and return stuff from the database as well. Now, the same infrastructure can be used to expose a gRPC service as well as a web service. So that cuts down a lot of code. So that means you don't have to create any marshalling layers in the middle, but you can just work with the core infrastructure and then expose different endpoints using the same entities. Now, how to choose these parameters? Choose the API protocols and data formats. Three things we talked about: parameters, guidelines, and then some examples. We have to take a look at the usability. Is it important for me to have lots of users, maybe a diviner who is trying to look at the API response to bind some data on the HTML5 site? Should they be able to use my API easily? And do I have to support all the browsers? Consider the case of HTTP3 where the Safari browser is not supported. So maybe whatever we use on HTTP3 will not be applicable. Then who am I building the APIs for? Am I building it for internal customers only? Am I building for partners who I have a little bit of leeway with? Or am I building for general public where I don't know who the client is going to be on what device they're going to run stuff on? Do I have any stringent performance requirements, or do I have requirements where the clients are constrained by the bandwidth of the compute power? So I have to consider all those things. Then am I building it for just the web systems, native systems, devices, whether they're mobile devices, IoT devices, and so forth? Do I need bidirectional access? Do I need to give live real-time information to the customer or not? And then in a cliche form, rich versus reach, right? A long time ago, when we used to build web applications, we used to think about whether we should build this ActiveX object-based AJAX client for the web browser, Internet Explorer 5, that would work very well for some customers, but not at all for any other customers. Or we should build a very okay-ish experience for the wide variety of customers, meaning reach, right, versus rich. But that's something we have to decide when we're working with the gRPC rich services versus REST services particularly. Now, guidelines, right? If you're building a public-facing API that has to have a very well-established documentation, interactive dev portal, where you can run some queries within the portal itself, and maybe then REST and JSON is a good option over HTTP 1.1. But when you have a system where you have some devices, they have to talk to other devices, maybe bandwidth is not at all a concern in that case, and then you can use gRPC and protocol buffers over HTTP2. But sometimes you'll have devices that are constrained, a satellite, or a rover, or a truck which has embedded system built into it. Maybe those are constrained, and maybe that's where you will use MQTT and JSON or protocol buffers. Because MQTT uses TCP, so you could use binary format of protocol buffers, or you can also compile JSON into binary as well, or you can use BSON as well, the Bison binary JSON. When you have inter-service communication, you have some services within within your ecosystem that have to talk to one another. We'll talk a little bit about their use cases. Then also it makes sense for us to use the gRPC and protocol buffers. When the services don't change, no maintenance is needed, and all we need is high performance, then you use the same option as well. Same cases I talked about earlier. When you have some gRPC services, you don't expose them RESTfully externally, then jam in the gRPC gateway in there. When you want to have the same service without doing much legwork on the web browsers, then gRPCweb. Right, and then also if you have real-time communication on the web, where you have some chat clients, etc., maybe WebSockets is a good example. And again, we don't have to talk about SOAP. And that joke is on me, really, a time machine, because I used to work on this SOAP a long time ago. Now let's take some examples as well, right? When to use REST and JSON or YAML or XML doesn't make a whole lot of difference nowadays, anyways, and GraphQL as well. In some cases here, you're building an API as a product, you want to commercialize that, and you want to have, maybe you're a cloud system, a financial company wants to use, who wants to expose some services, value-added services you have, or you have a service that has tons of different types of clients, which we don't control. Maybe a basic, most common denominator of REST services will be a good example in that case. A single-page web application where you're presenting the URL of the web application in the form of having entities like customer, person, etc., whatever. Sometimes you're building those applications and you want to map these endpoints of the service with the web UIs, URLs as well. Then it makes sense to use REST as well. Obviously, content management system that are just two CRUD operations. It's a great idea to just have basic RESTful interface using entities. Now, the second to last one that I mentioned, single page application and mapping the web URLs with entities of REST doesn't apply to GraphQL, because in GraphQL, you're only going to have one URL. You're not going to represent the URL with different entities. Now, gRPC and protocol buffer examples, I talked about internal microservice suite. A lot of companies have internal services that are not exposed outside, and they sometimes talk to one another as well. And we need to be fast, right? Financial services, aviation industry, automotive industry. There are lots of services and devices that are talking to one another inside. And gRPC and protocol buffers makes a really good example for that. And also you have inter-service communication for services that are actually exposed outside. They have endpoints that are public, but they also talk to one another. And they could talk to one another using a message queue, a pub/sub model, or something different. Or they could also be point-to-point. In those cases, you can jam in gRPCweb as well, gRPC and protocol buffers as well to have high performance. Or maybe just have TCP-based direct socket connection in some cases with some retries built into it. You also may have a device farm, IoT device farm, where we need fast performance, but there is no bandwidth concern. That also can use gRPC if the client supports it, obviously. Cases of I work with a web interface and I request a build. Build is taking some time. I want to know how long it has taken and where it is, and I want to be able to see the live status of my build or the infrastructure I'm provisioning, or a card issuance in case of payments industry where I work. You request a card, it goes through different stages to get the card issued, and then I need to know when I can actually jam it into my Apple Pay or wallet, other wallets, and when it gets produced, etc. So I want to be able to see some live status of that in the web. Also, for customer service cases, you're chatting with the customer service agent or people in social networks. WebSocket make a really good use case for those. Or you want to see live, news or a stock ticker, sports scores. Then also WebSocket and JSON will be a good idea. MQTT and JSON or protocol buffers, either or. You have a telemetry device. You can plug it into the cars, right? You want to be able to see how my car's mileage is, how the driving habits of this driver are, and then you may be driving through Montana where there's not much signal, but you still want to be able to receive as much data as possible. Then MQTT and JSON makes a lot of sense. satellite example I gave you, or the device that's running on a different planet altogether. So you won't have a lot of bandwidth to work with in those cases. Also, another example I'll give you is that in case of industrial IoT, where you have a truck, an earth mover, which is always working, but you're always looking at the instrumented data from it, and you want to make a decision when to replace its brake pads or hydraulic fluid, etc., and automatically send the repair person to fix the device. In those cases, also you use lightweight protocols. Um, and yeah, that's pretty much it. And you just quickly a recap. You want to take a look at some examples of in parameters guidelines, and then some examples. Sorry, I mentioned that again, of when to choose what. But happy to take some questions as well.